Okay guys, let's start with lecture 1 in power circuit and electromechanics. My name is Nguyen-Quang, and you can find my email address below on the first screen, on the first slide of any lecture. So in this lecture, we'll look at power in an AC circuit. So assuming we are looking at a load and we are applying an AC voltage across the load, so we will have the peak value of that voltage, the angular frequency here, and the initial phase angle for that voltage. So through the load, we will have a sinusoidal current with the peak value, corresponding frequency, and its initial phase angle. Now we define the instantaneous power, which is the product of that voltage and current, and we move a bit of our reference point. We will have current as a peak value when time is 0. So now we can calculate the average power, also called real power or active power, over one period t. After some calculation, we can find that the average power is the peak value of voltage and current divided by 2 multiplied by the cosine of the difference between the two initial phase angle, theta v minus theta I. We can also express this as V RMS, I RMS, and cosine of that angle. V RMS and I RMS are the root mean square of the voltage and the current. The difference of initial phase angle is defined as power factor angle, and cosine of that angle is called power factor. So here we have 4 definitions: average power, instantaneous power, power factor, and power factor angle. Because we are using sinusoidal, we can also use phasor to simplify the way we express. As you can see that the average power doesn't have omega at all, and therefore we don't need to use the angular frequency when we calculate average power. We only need the RMS value of the voltage and current, and also the phase of those phasor. So a phasor in this course is defined as with the module as the RMS value, and the angle is the initial phase angle, as you can see here. Okay, now we have a few situations because we have 2 phasor. So the voltage phasor here can lead the current phasor here, but when we talk about power factor, we always use the voltage as the reference, and we say lagging or leading is the current with respect to the voltage. So on the left hand side, we have 2 phasor V and I rotating counterclockwise with initial phase angle theta V and theta I. And in this case, current phasor is lagging with respect to voltage phasor. Therefore, we call this one a lagging power factor case. On the right hand side, the current phasor is now leading the voltage phasor, and therefore we have leading power factor in this case. So a lagging power factor is the characteristic of an inductive load, and a leading power factor will represent a capacity load. Is there any other power factor case? What if the voltage and the current are in phase? In that case, we will have a resistive load. Now, to help you understand the concept of phasor, okay, we will do some example. In this first example, they give you the expression for voltage, okay. They also give you the expression for the current. So to form the phasor, we need the RMS value of the voltage. So you need to take this √2 multiplied by 10 and divide it by √2, so that will give you 10 as the RMS value, which is the magnitude of the phasor. And also initial phase angle of this voltage will give you the phase angle of the voltage phasor. And then similarly, we will have 5 at the magnitude for the current phasor, and minus 20 degrees will be the phase for that current phasor. After we find voltage and current phasor, we can calculate the average power by multiplying the RMS value and the cosine of the difference between voltage phasor and current phasor. And in this case, we have a lagging power factor. Why? Because minus 20 here is lagging with respect to plus 30 here. So after some calculation, you have this power. In example 2, we will recalculate the power with the same voltage but different current. Now your current will have minus 90 degrees initial phase angle. So same magnitude but different phase angle. Applying the same equation, the same expression, we now find average power will be minus 25 watt. Okay, so what's the meaning when we have a negative power? Remember, on side 2, we assume that we are looking at a load. So when the load consumes negative power, it means it's not a real load. It's actually generating power.